Okay, so this is the second video having to do with logic, and we covered in the first one material in 9.1, 9.2. Now we're going to get into 9.3 and go a little bit into 9.4. So what we said before, we introduced the idea of statements, and we looked at some compound statements, and we looked at negation. And now we're going to look at truth tables. All right, well, truth table, you're going to do a lot of these in this section, in chapter 9, I mean. So you need to know how to do these, and they're basically a way of looking at all the different possibilities for the truth value of any statement. So and I said before is that all the statements, P, Q, R, anything that's going to be symbolized by one of those letters, that's going to be either true or false, which we use T or F to symbolize. And what we're going to do when we compound them is look at all the different possibilities and how they change depending on the compound of truth and false. So now let's start with the simplest truth table you're ever going to see, which defines, in some sense, the negation. So this is sort of a definition of negation. So if I start with a statement like P, and I consider all of its possibilities, it could be true or it could be false. Not too complicated, it could be true or false. Then what I'm going to look at is the negation of P. So if P is true, the negation of P has the opposite truth value. So if P is true, the negation is false. If P is false, then the negation of P is true. And this works just the same way it does in English if you add the word not to a sentence. So if P is the statement, the school is open. Well, if the school is open, its negation, the school is not open, is false. If I say the school is open and that's false, the negation, the school is not open, is true, the opposite truth value. So this is a very simple idea. I don't think you're going to be scratching your head too much over it, but it's a truth value definition of what that symbol means. That's the way to think about it, is that we have our linguistic, our verbal, our word way of understanding these things, but in symbolic logic, this is the real definition of what that negation symbol means. Let's go a little bit further now. We talked about some conjunctions last time. We talked about and or. Let's look at those in terms of a statement. And I'm going to need two statements for these because, as I said before, they're binary. So in P and Q, I'm going to need two statements. And this is a very important part of looking at truth tables, is I have to consider every possibility of P and Q being true or false. Now, P has only two possible values. It could be T, true, or F. But I'm going to put two truths and then two Fs for false, so that I can consider each of those with the two different values Q could have. Q could be true or false. Q could be true or false. Now, each line represents one of the four possibilities when you combine the two of them. It doesn't look that much different from a table you'd make up by flipping two coins, heads and tails. You know, if you had two coins to flip, there are four possible outcomes. They could both be tails. The first one could be tails, the second one could be heads. The first one could be heads, the second one could be tails, or they could both be heads. So the same thing works here. I have four possibilities, and this is a nice systematic way to make it up. So you'll see almost every truth table involving two statements starts with these columns. So after you've done a couple of them, you should get into a routine where you make them very quickly, right away, just like this. And if you're using lined paper, of course, it makes it easy to do. Okay. Now, what I'm going to do is I'm going to define one of the two conjunctions, one of the two compounding things that we already had. Let's look at the easier one first, and. And, symbolized by that arrow pointing up, the one that looks a little bit like a capital A, means this is a way of, this is the conjunction. This is conjuncting P and Q, or we'd say the conjunction of P and Q. Okay, how does it go? This will only be true when they're both true. If either one is false, or if they're both false, then the conjunction is false. The only way the conjunction can be true is if both statements are true. Okay, so this is an easy thing to make false. If either one or both is false, boom, it becomes false. So in truth tables, when you're looking at the conjunction, sometimes it's easier to fill in the falses first, and then whatever's left should be true. And we'll see that when we get to more complicated truth tables. So that is, in one sense, a definition of what that symbol means, that vertical pointing upward arrow. Now, in a different color, let's look at the same sort of setup but for the other compounding symbol, the OR. Okay? So we have P, we have Q. We have the same start, true, true, false, false, true, false, true, false. Now, you may be wondering, do I have to start my truth tables that way? Not really. But if you do it always the same way every time, it just makes it easier. So I'm going to set the example of doing that. I would suggest you do the same thing. You have to consider every possibility. And to be honest, if somebody's going to be grading your exam like me or an examiner, they're going to expect them to see them in this order. And if they're not, it makes it harder to grade. So just make it easier on everybody by following this example. Now we're going to put the arrow pointing downward for OR. So this is P or Q, the disjunction of P or Q. Now, which of this is true? This one's, in some sense, very closely related to this, but has something else, something new. This one, P or Q, is true if either one is true. The only way it can be made false is if they're both false. Otherwise, it's true. So just like this one, the and, the conjunction, is easy to make false. The or, the disjunction, is easy to make true. If either one is true, you don't even have to look at the other one. The disjunction's true. So when I look at these first two rows, the fact that P is true, it doesn't matter what Q is, they automatically are true. Over here, these two rows, no matter what P value has, the disjunction is true, because Q is true on those two. I don't even have to look at this one. So when we're filling out more complicated truth tables, those are little sort of shortcuts you can use. You want to make sure to keep straight that they're different that way. Now, there's another one we looked at in the last section, actually in section 9.1 or 9.2, it was the exclusive OR. So let's look at that one. This doesn't come up all that often. In fact, I don't think that marker is dark enough. Let me do it in blue down here. Okay, we got P, we got Q. We start off always the same. Okay, now let's look at P with the exclusive OR, okay? This is a different sort of disjunction. This one's true when they're both true. Okay? That's the one thing I got wrong there. It's not true when they're both true. Up there it is. Here, it's true if only one of them is true. If they're both true, it's false. And if they're both false, it's false. So this one is less common. That's the exclusive OR. It excludes the possibility of both of them being true. That's much less common. You won't see that turn up that much in symbolic logic. This it comes up a lot. But we talked about the disjunction that was more common. We'd use it in language. Usually it means this, the either or. All right, I'm going to go ahead and erase that one. I want to concentrate on these. Okay, so now you've had three truth tables. One for disjunction, one for and one for or. Those are the three most basic kinds, okay? Now another thing they talk about in 9.4 is they also get up to and talk about using Venn diagrams to represent sets as a way of understanding symbolic logic. So I want to show you a little bit of that. This should remind you of what you studied before in set theory, and that was in the last class in PSL. So if you need a little bit of review for that, look in your textbook for the set theory section and go back and look at it. But let's look at it in terms of the Venn diagrams here. If I'm looking at P and Q, if I think of P and Q as sets, here's P, here's Q. Now if I want to shade the set corresponding to P and Q, that's going to be the intersection right in here, where they overlap. So that's P intersect Q. P intersect Q in set theory corresponds to P and Q in logic. Now, if you look at the symbol, you'll see exactly why they chose this symbol. That's a sharp, pointy upward arrow, and it looks very much like the rounded symbol for intersection that they use in set theory that is also pointing up or open at the bottom. Now, you can probably anticipate what's going to happen over here when I look at the sets P and Q again, and then consider P or Q. Well, that's going to be the union here. All the points in each set. These correspond in set theory to what we get in logic. And so once again, the sharply pointing downward arrow there is replaced by the rounded hoop-shaped union symbol here. And so there's a very close correlation with those. We tend to use set theory whenever we get a correlation like that because it's very visual and it helps us understand things. Symbolic logic is not very visual, so these could be used to try and make it more easy to see. Now I want to look at two problems from section 9.4. I want to walk through those and look at the answers to them. So let's look at 9.4. We're looking at problem 2 in 9D. Let me show you exactly where it is in the textbook. Let's erase this first. Okay. And then let's look at 9D in the textbook. That's section 3, dealing with truth tables. We're going to go back to section 2. I'm sorry, 9.4. 9D is what I want to look at. And this is the truth table in the textbook for negation. All right, and you notice there's some things they put on the side here well worth reading. What this one says is the negation of a statement sometimes can be confused. If I say my statement is Jan is the tallest person in class, the negation isn't that she's the smallest person in class, it's just that she's not the tallest. You'll also notice another set theory correlation here between negation and complement. The complement of a set is very similar to the negation of the statement that corresponds with it. That's 9C. Let's go up to 9D. There's 9D. All right. Now, let's look at problem 2. All right, let's zoom in a little bit here, make it a little easier to read. Okay. Now, problem 2 gives meanings to P and Q, and then asks for linguistically to spell out what each one of these is. So in each one of these, you have P and Q, not P and Q, P and not Q, not P and Q. This is the negation of the conjunction P and Q. This is not P and Q. Notice how we have parentheses around this. We're going to get to using brackets for compound statements and negations coming up. I've assigned number 1 to you. I'm going to do number 2 as an example. Okay? So that is 9D, and it's on page, well, what page are we on here? Let's see if I can just drag it over. 389. Page 389, okay? Jorge speaks Portuguese, Mei-Ling speaks Malay. All right, so let's go through what all of these are in these symbols. Now I'm going to move that out of the way, and now I'll rewrite them. Okay, so the first one was P and Q. I think that green one doesn't show up very well, so let's look at this. P and Q. Okay, so the first one asks for the conjunction. So how do you put that in words? I'm going to abbreviate Jorge with a J, Portuguese with a P, Mei-Ling with an M, and Malay with an M. So what I would say is for P and Q is you say Jorge speaks Portuguese and Mei-Ling speaks Malay. Okay? That's A. And what about B? B asked for the conjunction of the negation of P and Q. So we have not P and Q. Okay. Well, that means Jorge does not speak Portuguese and Mei-Ling speaks Malay. All right. What about C? C said it wanted P and not Q. P and not Q. All right, well that says Jorge speaks Portuguese and Mei-Ling does not speak Malay. All right, D says not P and not Q. Okay. Okay? That's Jorge does not speak Portuguese. And Mei-Ling does not speak Malay. Okay. Last one, the negation of P and Q. Okay, so we negate P and Q. Now there's more than one way to say this, but probably the easiest way is to use the word not and then say the conjunction. So basically you say it's not the case, it is not the case. That, and then I write P and Q. Jorge speaks Portuguese, and Mei-Ling speaks Malay. Okay? I could say it's not the case, or it's untrue that Jorge speaks Portuguese and Mei-Ling speaks Malay, something like that. All right? And it could be by having either one of these not false or both of them. So that's what the negation of the conjunction means, okay? Now let's move on and look at a truth table. You've got those questions, and their answers are in the back of the book too. So you can look them up if that was a little too fast, you didn't get it written down, or you don't understand by my example. Take a look at the back of the book, you'll see it all spelled out. I want to go through how you find that answer, as well as just what the answer is. So now let's look at number 11 in 9D. So there's 9D, number 11. Okay, let's take a look at the book. This is 9D. And here's number 10. Then we go on to the next page, there's number 11. Okay. Let's zoom in. Okay. Too far. There. Okay, consider these statements. Say Jim came top in mathematics. Say Jim came top in English. Write the statement. Say Jim came top in mathematics, but not in English in terms of P and Q. So we're going to use P and Q. Notice that this English word but isn't involved in symbolic logic. We don't use that. We use the and form in here. All right? And that's what we're going to do. We're going to construct a truth table showing how the truth value of R depends on the truth values of P and Q. Okay, so this is number 11. Now let's get a blank slate. Okay. Here's what we want. Statement R said that P was true, but Q was not true. All right, P was true, but Q was not true. So we're going to say P and not Q. That's the way to symbolically write P, but not Q. It doesn't use the word but, that's just used in English. That's the statement that, say, Jim came first in math or whatever and not in the other subject. So that's the symbolic form that the statement has. Okay, now it said let's look at a truth table. Let's look at a truth table of P, Q. We're going to make a truth table that has this whole thing in it. So I'm going to need P, and I'm going to need Q. So we start off all our true value, two statement truth tables, like so, to consider all the possibilities. And you might notice it is important to make your T's and F's look very clear. You don't want something that you can't figure out whether it's a T or an F. Now, I want to conjunct P and not Q, so I'm going to need not Q. Let's figure that one out first. So this will flip all the truth values of Q from whatever they are to the opposite. Okay? So that's not Q. Now I want to conjunct P and not Q. So I'm looking at these two columns and I'm ignoring this one. Now here's what we want to do. We want to make sure we remember what the conjunction does. The conjunction's easy to make false. If either one's false, the conjunction is false. So look up here. P is up here. Oh, there's two falses here. So I know those two will result in the conjunction being false. Okay, now let's look at this column. Anywhere this is false, I get a false. So I get this one. But that one's true, so I'm going to leave it alone. On that line, P and not Q are both true. That'll be the only line where the conjunction P and not Q is true. So that's the answer to the question it asked. It said show a truth table and show how the truth of this depends on the truth of P and Q. So what we do is we go to look at this. It's only going to be true on this line. So go back and look at it here. This statement, R, is only true when P is true and Q is not true. That's the only time it's true. Otherwise, it's going to be false. So that's the examination they asked for. Okay. So there. Now at this point, we've covered the material in 9.1, 2, 3, and 4. We did a little bit out of order. We didn't do it exactly the way the book did, so you want to go ahead and read those sections, and we'll be prepared in class then to work the exercises assigned in 9.1, 9.2, 9.3, and 9.4. So that'll be, like A, B, C, and D. So we'll catch up with that in class. Be sure to do the reading before you come to class, and if you find that the videos don't help you as well until you've done the reading first, then that may be what you need to do. Do the reading first and then watch the videos. All right.